Right behind laser welding in the battery processes are the various challenges in dispense. As material sciences for low specific gravity and highly thermally conductive materials continues to evolve, thermal interface material, or TIM, are becoming less abrasive, less damaging to process equipment, and even injectable in some cases. The optimum distribution of TIM will promote battery cooling in more effective ways while keeping weight down. While not suitable for all battery products, the application of TIM is a key process step, requires substantial equipment investment, and can be iterative to get it right. TIM is almost exclusively a two-component material, and thus must be metered carefully. It's typically heavy and highly abrasive. A common approach is to mount the servo metering equipment to the elbow of a 6-axis robot and allow the robot to trace the desired pattern. And provided there's sufficient cycle time, this is a highly flexible and suitable approach. However, this may not produce the required volumetric flow to meet total throughput, and thus additional stations may be required. This multiplies the capital cost of the dispense and motion platform equipment. ATS has experience in developing robotic systems for maximum flexibility, as well as bespoke dispense solutions that optimize pattern density and volumetric flow for the given equipment footprint. After TIM is dispensed, it's typically concealed in the product and never seen again. Knowing that you've dispensed the correct amount of material in the correct location is critical to a quality product. Real-time volumetric monitoring through laser scanning tools can measure the profile during dispense and guarantees the correct amount and shape of material was applied. And TIM isn't the only critical dispense operation in the wide variety of battery manufacturing applications. Batteries can be exposed to a number of environmental conditions, and in some cases, high vibrations. In some products, securing the batteries to a carrier is important to keep them well supported and remove the stress from sensitive weld joints. To make a quick example, in order to secure our customers' batteries, ATS, along with our dispense partner, built automation which could rapidly jet dots of UV curable adhesive to the carrier substrate, which was approximately 50 millimeters away with a 1 millimeter accuracy. This permitted precision dispense of the adhesive in a programmable pattern at high speeds to maximize throughput while maintaining adhesive holding power. Potting, used in applications such as final battery retention or bonding of thermocouples for temperature monitoring, is often another key dispense process found in battery automation. Not to mention other dispense applications, including flux and cleaners, product sealants, and electrolyte fill, which you can see here. Knowing that batteries in either modules or packs meet their desired metrics is essential to validate key processes before ramping up to production. Whether incoming cell inspection, such as open circuit voltage measurement, or leak testing on the coolant circuit, each successful production line has both inline and offline testing to help minimize scrap and ensure a quality product. Other essential testing requirements are likely to include high pot test, DCIR testing, and low voltage circuit testing to validate the battery internal voltage monitoring system is functioning correctly. To couple with connection points on the battery, module, or pack, the automation tooling may require custom connectors to ensure long-lasting and reliable contact. On the back end of testing is the data banking of all this information, so each product has a credible birth certificate right from the production floor to the final consumer.